Hello guys, welcome back to my channel. Today we are going to learn about DCC reagent, which is called Dicyclohexylcarbodiimide. We'll see its mechanism, its uses and stereochemistry in this video. So we'll be solving some problems and its solution to find its application. This is my second video on reagent. First I have prepared on LDA. If you haven't seen it, you can find the link of that video in the description box of this video. If you want me to prepare any particular topic video, you let me know in the comment box, and also do write the feedback of this video in the comment section. So let's start. DCC, dicyclohexylcarbodiimide, and its structure is represented like this, where you have one carbon with two nitrogen and two cyclohexyl groups. It is a powerful dehydrating agent, and so it is used wherever you require to lose a water molecule. You can use DCC reagent and take the advantage of it. It is stored in the anhydrous condition, and so you can prepare esters, ethers, anhydrides, amides, lactones, peptides and lactams, etc. with the help of DCC reagent. Let's see this example where we have two molecules, one is acid, another is alcohol. The DCC is giving to you. So basically we know the role of DCC. It is acting as a coupling agent, or also it is a dehydrating agent, and you can show the loss of water from this and forms the esters. So this is the esterification reaction, and we'll see how DCC is releasing the water in the form of mechanism. So first we will react the DCC with the acid molecule. You have a nucleophile in acid, oxygen, and the carbon in DCC is an electrophilic center. So the reaction will take place between these two and will give you this intermediate, which will form a bond. It gives its electron to the hydrogen plus, so in acidic condition, and gives you another intermediate. Now you have other reactant which is acting as a nucleophile, the oxygen of the alcohol, and we know the carbonyl carbon acts as a electrophilic center. So the nucleophilic electrophilic center reaction will occur and gives you the intermediate, where you can show the release of DCC in the form of dicyclohexylthiourea, and it gives you the ester as the product. So this is how the loss of water takes place, and finally you are getting the ester product if acid and alcohol is given to you. Now see some examples. You have here again an amino acid is given, alcohol is there. And in the presence of DCC, we know loss of water, and usually the water molecule, the OH comes from the acid and hydrogen comes from the other reactant and gives you the ester here. This is esterification reaction. The second example, two acid molecules are given in the presence of DCC. With the loss of water, it gives you the anhydride. You can use the same mechanism. Acid and amide, if you react with the loss of water in the presence of DCC, gives you amide. Here again you can notice with the color differentiation that OH goes from the acid. In this case, the two alcohols are given. So this is the etherification reaction with the loss of water in the presence of DCC, and you will get the ether. You can design ester, anhydride, amide, ether with the help of DCC. In this case, only one reactant is given in the presence of DCC, and we know the role of DCC is the loss of water. So it is basically going to happen intramolecular loss of water, and it will give you the beta-lactam product. How? We will see. So we know that you have a nucleophile in the acid and you have electrophilic center. So you will get this intermediate. Intramolecular, again you have NH2 as a nucleophile which will attack on the adjacent carbonyl carbon, which is a electrophilic center, and gives you the cyclic intermediate. And with the electron rearrangement, it will show you the release of dicyclohexylthiourea and gives you the product beta lactam. This is how you can design beta lactam from beta amino acid in the presence of DCC. In this case also you can see it is intramolecular dehydration reaction. You have gamma hydroxy acid, so OH will release from the acidic group and hydrogen comes from the alcohol. The stereochemistry is mentioned here. So basically DCC retained the stereochemistry, so it will give you the lactone with the same stereochemistry. In this particular case, you have two reactants. You have acid and alcohol with this stereochemistry mentioned here. In the presence of DCC, you can show the loss of water. The OH comes from the acid with the retention of stereochemistry. You can use the same mechanism. Now, two acidic groups in the presence of DCC, intramolecular loss of water gives you anhydride as a product with the retention of stereochemistry. Now, with the presence of DCC, wherever it is possible, you just show the loss of water. You have acid, you have diazomethane, acid OH is going to release, you take the hydrogen from the diazo group and you will get the alpha diazoketone. Same reaction, you have two acid molecule in the presence of DCC, so basically anhydride formation will be there. The second reagent is given here, hydrogen peroxide. In the presence of hydrogen peroxide, anhydride will convert into peroxide. So final product is peroxide. Same reaction again, you have two carboxylic group at ortho position. In the presence of DCC, show the loss of water with the anhydride formation. Now you have an amino acid and you can see OH is there. You have NH2 group in this other reactant. In the presence of DCC, you can show the loss of water and form a new amide bond linkage. In that way, you can design peptides in the presence of DCC. Now in this case, you can say that you don't have acid, right? And you don't have here ether as well. But we know we have DCC which is acting as a dehydrating agent. So wherever it is possible, you show the loss of water and you can form the alpha beta unsaturated ketone in this case, which is more stable as compared to the starting material. Similar kind of example, you can show the loss of water in the presence of DCC, which gives you the alpha beta unsaturated ester. So not only the ether ester amides, you can also design alpha beta unsaturated ketone and ester in the presence of DCC. So this is what we have learned today about DCC. You can take the advantage of this video to design the stereochemistry and see the applications. Happy learning. See you in the next video.